All right. So I want to go through the practice problems that I have assigned at the end of the PowerPoint regarding the confidence interval for the mean. And let me go ahead and bring up the PowerPoint here for a minute. So this would have been Tuesday's lecture, which I believe is lecture 17 on the PowerPoints. There we go. And we'll open this up, take a look. And we'll go to the end of the PowerPoint. By the way, it isn't a bad idea actually to work through the example that we gave in class. So the data set for that is on modules. It's called data set salaries. So it's not a bad idea to actually work through this and convince yourself that you understand these steps and you can replicate it. I think one thing that you should bear in mind is that the goal of this class is not to do a lot of problems. It's to understand one problem well. And if you really understand this one problem well, it will put you in good position to understand the others. So these are the basic skills that we need to do. We need to be able to compute the standard error, which we said was the estimate for the standard deviation of x bar. And the way we compute it is we take the sample standard deviation s and divide it by the square root of n. The critical value, which we're going to have to use the z-scores and the confidence. If we don't know the population standard deviation, we're also going to have to use the sample size in computing the critical score from a t-distribution. The margin of error, which is the product of 1 and 2, the product of the standard error and the critical value. And then we compute the confidence interval by just saying the point estimate x bar plus or minus the margin of error. Recall we said that the way we interpret the margin, the way we interpret the confidence interval is that we're confident with a certain degree of confidence that the value for mu is in that interval, but it's not the probability. And finally, we talked a little bit about the output from StatCrunch when we run a test with data. And of course, the assumptions that we need to compute the confidence interval are exactly the same assumptions we need when we run a hypothesis test on the sample mean. So this would be something good to review because it does double duty. You need it for two different instances. Okay, so if we look at the first problem, it says a survey of randomly selected customers found the ages in years. So in other words, they took a random survey of 25 people and they asked them their age. The mean was 31.88. The standard deviation is 10.7. And we want to know the standard error for the mean. So we want to use this fact that the standard error is equal to the sample standard deviation divided by the square root of n. And so one way to do that is just take the sample standard deviation, which is s, and then just divide it by the square root of n. Interesting. Okay. So this is just going to be equal to s divided by the square root of n. Let's see if this works. Well, it's not going to let me input this. Try it one more time. Let's do this. Yeah, there we go. Okay. So the standard error is equal to the value of S divided by the square root of N. And we just put in the numbers. So we have to be able to find these numbers, right? So the standard deviation, it came from the sample in this case, so you have to be a little careful. The way we know that is everything's referenced with respect to the sample, right? So it's 10.07. And I'm just going to write it like this because this is going to be a bit of a pain. Divided by the square root of 25. That's our sample size, which is 5. And you go ahead and do this, and you should get 2.014. And that's our standard error. What if the sample size had changed to 400? Well, notice the only thing that would have happened was instead of dividing by the square root of 25, I would have just divided by the square root of 400, which is 20, right? So I would have just had 10 divided by roughly 10.07 divided by 20, which would be a little more than a half. It'd be around a half. So notice that as the sample size goes up, the standard error goes down, and that makes sense because the standard error is the estimated standard deviation for x bar. And we know from the central limit theorem, as the sample size goes up, the standard deviation of x bar goes down, so the estimated standard deviation for x bar should go down too. Okay, the next problem says, suppose we're making a 95% confidence interval for a population mean, and we have a sample size of 15. What degrees of freedom should we use? And here you want to use the fact that for a confidence interval for the mean, the degrees of freedom, which are denoted by df, is n minus 1. So in this case, this would be 15 minus 1, or 14. And you're going to need that when you go ahead and compute the confidence interval. That's one of the two things you're going to need. You're going to need the degrees of freedom, and you're going to have alpha over 2, which is 1 minus the confidence divided by 2, when you go to compute the critical value for the margin of error. So now we get to the critical values. So it says we want to find a critical value of t for a 90% confidence interval with a degree of freedom of 21. So here they've told us the degrees of freedom. So all we need to do is we need to figure out the probability in the tail. So what we're going to put in, it's going to be equal to 1 minus 0.9, that's the confidence, divided by 2, or 0.05. So this is going to be the probability in the left tail. And how would that work in StatCrunch? Well, we would just go to here, and we would say we go to Stat, Calculator, like we've done before, except now instead of going to normal, we go to T. Our degrees of freedom are 21, and the probability in the left tail is 0.05. And so this will be our critical value. Now you have to be a little careful because sometimes they want you to use positive critical values. And that's the reason why is because they want the margin of error to be positive. So I'm going to go ahead and just take this right here. Just snip this off. And so my answer should be this. What if it was a 98% confidence interval? Well, I would have 2% in the tails, both tails. The probability in the one tail would be 1%, right? So now the probability that I'm going to enter, all I would do is just change 0.9 to 0.98 and divide that by 2, and that would be 1%. And so I would just redo the calculation, except I would change the degrees of freedom to 81. and I would change this to 0.01, right? And compute it. And I'm going to take the positive part of that, and that'll be my critical value. And that's the hardest part of computing the confidence interval. Go back, put this in, and voila, there we are. Of course, your numbers will differ, but just, you might want to verify that you can get mine, and then you have some confidence, pardon the pun, that you can do yours. So hoping to lure more shoppers downtown, the city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees. They take a random sample of 43 workdays. So right here, I know that this is my sample size right here, 43. And the daily fees collected averaged 133. This is my sample mean. This is the average. And the standard deviation is 15. And this is a sample standard deviation because it comes from the sample. So it's a good idea just to kind of understand from the very beginning what we're working with here. So n is equal to 43. X bar is equal to 133, and S is equal to 15. So this is my given information. What assumptions do you need to make in order to use these statistics for inference? So notice what we just said when I looked at the first slide. I said no matter what type of inference you're doing, whether you're doing a hypothesis test or whether you're doing a confidence interval, you need the same assumptions to be met, right? So first of all, we have a sample size of 43. That's relatively large, okay? So we would need the data to be a random sample of all days. So that's important. We need independent data values, okay? And they should be random because we want the data to mimic the population, because we're trying to make generalizations about the population. That's why random is necessary. So this is going to ensure that our estimates are accurate. Okay? And in this case, the sample size isn't huge, and we're working with financial data. So I would say that we want the distribution to be unimodal and symmetric. Sometimes it could be a little bit of a coin toss. You might say, well, 43 is large enough, I wouldn't have to worry. But to be on the safe side, this is what we would assume, right? If I had a super huge population, like 100 or so, I probably wouldn't make any of those assumptions, right? I could just use the data and wouldn't have to worry. But we're still in this kind of middle region. I mean, you remember when you did activity 3, when you took sample sizes of 25, things still sometimes didn't look normal. Okay, they still had a skew. So, all right. So here you can use StatCrunch, or you can do it by hand. I would use it by StatCrunch. Okay, so here I have a data summary. So what I can do is I can enter all that information. Remember, we had this information. In fact, this is the information right here, right? And I'm just going to put all that right in. So I'm just going to go back, take that, oops, copy this, and paste it, and then I'll use that in the problem. So notice we can go to StatCrunch now, and we can use what's called a data summary. So now I'm going to go to Stat, Tstat, one sample, and notice I have my choice. So in class we did data. We used the 6 salaries, and we did it using the data. But here I have a summary of the data. In other words, I'm told what the sample mean is and all of that, right? So I'm told the sample mean is 133. I'm told the sample standard deviation is 15, and X bar is 133. Hold on, let me make sure that's right. X bar and 43 is the sample size. Okay. And I have to be careful. I have to go back and make sure I get the right confidence, okay? So it's asking me for a 90% confidence interval. So now I'm just going to set the confidence at 90%. And I'm ready. You can do a plot. I usually don't do it. The plots really aren't that good for confidence intervals on StatCrunch. And so now remember, we have to figure out how to read this, right? So I'm just going to go ahead and paste this in. In fact, I've already done it down here. And so you can see that this is the lower limit. In other words, this is the lower endpoint, 129.15. I'm going to round that off to 2 decimal places. So the lower limit will be 129.15. And there's this thing called upper limit. That's the upper endpoint. And if I round that off properly, that's going to be 136.85. Okay. So this is another way to do confidence intervals in StatCrunch, and it's actually much easier. If you didn't do it using StatCrunch, you'd have to compute the standard error, which we could do. It would be 15 divided by the square root of 43. And then I have to compute the confidence interval. I have to compute the critical value. And my degrees of freedom would be 42. And the probability I'd put in the left tail would be 5%. And you could do that, but it's a lot more work. Okay, so now we have to interpret it. So hoping to lure more shoppers downtown, so we know the problem statement. Explain in context what this confidence interval means. And I want to go through all of these to kind of pick out what's wrong, explain what's wrong. So it says, and I want to remember that this is the interval, okay? So this is the interval 129 to 136.85. So when they say this interval, this is what they're referring to. So this is the 90% confidence interval that I got using one particular data set. So let's go through the different options. So the first option is there is a 90% confidence that the interval contains the mean daily income. So let me start with A and I'll work down towards D. Okay, there's 90% confidence that the mean daily income will always fall in the interval? And the answer is no. They're referring to this specific interval. So they're saying there's a 95% confidence that the true mean will always fall in this interval. And the answer is no. We can't say anything about a single interval. So there isn't a 90% confidence that it will always fall in this interval. There's a 90% confidence that the daily income for a weekday falls in this interval. And again, for the same reason, let me think about this for a second. There's a 90% confidence that the daily income for a weekday falls in the interval. Let's put a question mark next to this for now. So let's rule out the ones that we know for a fact are wrong. So we know that the first one is wrong because we can't say anything about there's not a 90% confidence that it always falls in this interval. This particular interval. Okay. There's a 90% confidence that the daily income for all weekdays falls in the interval. Okay, so now we can kind of figure out the difference between these two, right? So this is a sample average. So they're saying there's a 90% confidence that the daily income for a weekday falls in the interval. Well, this is false. First of all, this is referring to a mean, right? This isn't referring to the daily income. So we can't talk about a single day. We're confident that the population mean falls in here, but for a single day, we don't know anything. So that's why that's wrong. So these questions, they really require that you read them carefully. All right. There is a 90% confidence that the daily income for all weekdays falls in this interval. Well, this is wrong. This is saying there's a 90% confidence, and this is kind of a variation of B, right? They're saying that the income for all the weekdays falls in this interval. Well, this isn't what the interval contains. It contains the average of all the days. Okay? So it's exactly the same problem. So D is the only one left. There's a 90% confidence, and this is really saying that mu, right, that the interval contains mu. The interval contains the mean daily income. So the answer is D. So these questions you have to read really carefully. Again, notice the difference between B and C and D. B and D are talking about daily income, and this contains the mean. This doesn't say anything about a single day. This is talking about the population mean. We're 90% confident it's in here for all the weekdays. So hoping to lure more shoppers downtown, this is the same problem, right? So it says, explain what a 90% confidence interval means in this context. So we know the answer, and now we're just going to try to morph it into one of these. It means and then I drew this as a little guide, right? A 95% confidence interval means that 95% of the intervals contain the true value. So this is what we're going to say roughly. We're going to say that 90%, for a 90% confidence interval, 90% of those confidence intervals, so 90% of the samples will have confidence intervals that contain mu. So let's figure out how this works. So it says 90% of all samples of size 43 have a main daily income that is in the interval. No, that's not what it's saying, right? We don't know anything about where the sample means are going to go. We don't know that they're in that interval. We only know about the population mean. So A is not correct. See if that still works. Yeah, good. So it says that 90% of all samples of size 43 produce intervals that contain the mean daily income. That looks correct. 90% of all weekdays have daily incomes that fall in that interval. Again, it's talking about the mean and it's talking about the population mean. So C is totally wrong. Whoops. So C is not correct. And finally, D. Move it down there, come on. 90% of all weekdays sampled have incomes that fall in that interval. And again, that's not true. It's the interval, right? So 90% of all weekdays sampled have incomes that fall in that interval. Again, it's the averages that fall in that interval, and it's not the averages from the daily samples from the individual days. It's the average from all the days. So the answer must be B. And last, interpreting confidence intervals. So this is kind of what we were going towards last time when we were talking about how hypothesis tests are the same as confidence intervals. So it says, so remember that this is the confidence interval down here. The consultant who advised the city on this project predicted that parking revenues would average 130 per day. Based on the confidence interval, what do you think of the consultant's prediction? Well, notice that he predicted the average would be in one of the possible values that the average could be. In other words, we say that the population mean could be anywhere from 129.15 all the way up to 136.84, and his prediction fall in that interval. So since the 90% confidence interval contains his predicted average, the consultant's prediction is plausible. In other words, the data supports his prediction. These are good problems to go through. Please go through them, try to understand them. If you have any questions, come and see me about them. Thank you.